Okay, welcome back. Let's go ahead and move into section 1.2. Okay, angle relationships in similar triangles. Okay, so one of the relationships in a triangle is that the angles all add up to 180 degrees. So angle A, angle B, angle C are all going to be equal to 180 there. Okay, the other angle relationship that we have here is vertical angles, which are angles opposite a vertex. This is a vertex. Angles opposite a vertex, those are equal. Alternate interior angles, A and B here, are also equal. Alternate exterior are also equal. Okay, so corresponding angles, angles that are the same angle, sorry about that, are the same angle on a transversal. This red line is called a transversal because it transverses parallel lines. They're in the same position, but just on a different line. Okay, same position, just a different line. Those are equal. And then same side interior, these are not equal. So I'm going to put two lines there to show that it's not equal, but they do add up to supplementary, which means they add up to 180. So A plus B here, although they're not equal, they do have a relationship in that they add up to 180. Okay, supplementary. So we want to see what's going on in example 7 here. It says find the measures of angles 1, 2, 3, and 4. Okay, we know that this angle here, which I'll highlight, 7x minus 5, that guy is going to be opposite, or it's opposite to angle 2 here, angle 1. Those are, they make up a line. Okay, and so they would add up to 180. I want to relate though angle 4 and this 7x minus 5. So I do know that 7x minus 5 is the same as angle 3. Okay, this 7x minus 5 is the same as angle 3 because of corresponding angles. These corresponding angles over here, okay, are the same as, corresponding angles. They're going to be equal. So I do know that this 3 is really 7x minus 5. Oops. Write that a little nicer. 7x minus 5, and the 3 and the 4, they are, what we've already seen are what's called a linear pair, and they are supplementary angles. So 3 and 4 are supplementary angles, which means that they add up to 180. So I do know that angle 3 and plus angle 4 equals 180 degrees because they're supplementary, they're linear pair, they make a line, they're a linear angle. Okay, and so 7x minus 5 plus 9x plus 9 is equal to 180 degrees, substituting that in. And we get 16x plus 4 is equal to 180. I'm going to subtract 4. I get 16x is equal to 176. Divide by 16. And I get x is equal to 11. Okay. So we know x is equal to 11. That doesn't tell us what the angles are. It just tells us what x is. So I can go back in. I can say, okay, well, what's 7x minus 5, or 7 times 11 minus 5? Well, I know that that's 77 minus 5, which is 72 degrees. Okay, so I know that this angle was 72. Maybe I'll use a different color. This angle was 72 degrees. Therefore, angle 3, 72 degrees is angle 3. So this angle had to be 72 degrees. Okay, if angle 3 and 4 are supplementary, that means that they have to add up to 180. So what's 180 minus 72? That's 108. Okay, so I know that angle 4 had to be 108 degrees. Okay, and angle 3 and 2, they are also supplementary because they are same side alternate interior angles. Okay, they're same side interior angles. 2 and 3, these are going to have to add up to 180, so this has got to be 108. And vertical angles are 1 and 2, so that's the same, so that's 108. So we got 108, 108, 72, and 108. So angle 1 was 108, angle 2 was 108, angle 3 was 72, and angle 4 was equal to 108. Okay. Let's categorize the type of triangles. So the first triangle is an acute triangle. That means that every angle in here, they're not all the same angles, but every angle is less than 90 degrees. Okay, the angles are less than 90 degrees. Okay, so every angle is less than, so this has the 3 acute angles. That's why it's called an acute triangle. Okay, it has all 3 angles that are acute. Okay, they don't have to be the same, but they are less than 90. Okay, or acute. Right triangle has 1 right angle. It can't have 2 right angles because then it wouldn't be a triangle. Okay, it would be kind of this open box. No way to have 2 right angles in a triangle. We can't have 1 though. And if we have 1 right angle, then it's called a right triangle. Okay. And this little kind of looks like a less than symbol, but it really is an angle symbol. That's what this symbol is there. It's an angle symbol. Kind of looks like an L. You wrote an L, but bent it. Okay, you bent the L. Here's L, and then you kind of bend the L over. Okay, that's your angle symbol. This means angle. Okay, I guess I should write it like this. It's hard to see. Okay. Excuse me. Okay, so three acute angles, 1 right angle, and then 1 obtuse angle is an obtuse triangle. One obtuse angle gives me an obtuse triangle. Okay, we can also categorize triangles by sides. Equilateral triangle, I'm going to use these tick marks to say, hey, you know what? All 3 of those sides are the same. They are congruent. So 3 congruent sides is an equilateral triangle. Isosceles triangle has 2 sides that are the same. So 2 congruent sides. And a scalene triangle has no sides that are the same. They're all different. So no congruent sides. Okay. Okay, similar triangles have the same shape, but not the same size. So if it's similar, it's the same shape. Okay, so maybe we have a right triangle that looks like that. Same shape, but one just kind of is the mini-me of the other one. And we use this little squiggly mark, this little tilde, to designate similarity. So this is similar. Okay, if the triangles are congruent, means that they have both the same shape and the same size. So everything would be the same about them. So if I had, say, 3 or 2 congruent triangles. Okay, so we have these 2 triangles, and if the angles are all the same, and the sides are all the same, we've got 3 sides and 3 sides and 3 angles that are the same. Then we say they're congruent, and we use a little squiggly mark with an equal sign above it. Okay. Conditions for similar triangles. Given 2 similar triangles are the same, following following conditions hold. Corresponding angles have the same measure. The ratios of corresponding sides are equal. So corresponding angles have the same measure in a triangle. So again, if we have similar triangles, okay, then let me make this a little bit more similar-ish. Okay, then say that this angle here was a, I don't know, 80-degree angle, then this one's 80 degrees. If this angle is, say, 40 degrees, then this angle is 40 degrees. And if this one is 60 degrees, then this one is 60 degrees. Okay, so even though the sizes are different, the angles are the same. Okay, now the ratios of the sides are equal, and the ratios aren't always necessarily the same. It could be, say this side could be 1 and this side could be 1/3, okay? But if this side is 2, then this side would have to be 2/3. And if this side was 3, then this would have to be 3/3, which is 1. So they're always in proportion to each other. The sides are always in proportion. So let's look at examples 8 and 9 here. Triangles DEF and GHI are similar. Find the missing side lengths of the triangle DEF. Okay, so they're similar. They're telling us they're similar, but we want to find the missing sides. We know that corresponding sides, DE and GH, those have to be proportional. So I know DE to GH has to be the same as DF to GI. Okay, so DF to GI. So DF to GI. Okay, so DE, that guy is 12 to 8, has to be the same as DF, which we don't know what DF is. I'll call that X for right now. But we do know that GI is 10. Okay, so I'm going to cross multiply and divide. So this becomes 8x is equal to 12 times 10. And so 8x is equal to 120 divided by 8. And x is equal to 15. And so we knew that DF had to be 15. Okay. Let's use the same logic on FE. So we're going to say that DE or the 12 to 8 to GH is equal to EF or FE to IH. Okay. So we're going to say that this again is 12 to 8 is equal to FE, which I'll call Y in this case, just to give me a different variable. And then IH is 12. So this time I'm going to cross multiply, and I get 8y is equal to 144 divided by 8, and y is equal to 18. So what X was the DF, and in this case Y was so DF was equal to 15, and FE is equal to 18. So we have that 18 there. Okay, exercise 9. A tree casts a 38 feet shadow at the same time Joey casts a 42-inch shadow. Okay. So we have a tree that casts a certain shadow. Joey, which I'm going to assume is smaller than 38 feet, casts a similar shadow because maybe the sun is up here. Okay, and the sun's rays are going to hit the tree. Okay, and they're going to hit Joey's head as well and create a shadow. Okay, so there's Joey. Okay, so the tree is 38 feet tall. 38 feet tall, or sorry, the tree casts a 38-foot shadow. Thank you. So 38-foot shadow is what the tree casts. At the same time, Joey casts a 42-inch shadow. Okay. And Joey is 63 inches tall, 63 inches tall. And we want to know how high is the height of the tree. So we're going to make that H. Okay, now we would normally have to reconcile our units. In this case, what I'm going to do is I'm going to make it so that we relate Joey's shadow to his height. So the units are going to cancel out, which is really nice. Otherwise, I'd have to change everything to either inches or feet. And so here we have H is over 38. So H to 38 is 63 to 42. H feet to 38 feet. And again, the units cancel out, which is nice. So I can use this proportion. I am going to cross multiply. And so I get H times 42, or 42H, is equal to 38 times 63. So 42H equals 38 times 63. Let's go to the calculator for that one. Okay, so 38 times 63 divided by 42. Oh, let's not divide just yet. 38 times 63 is what? Oops. 38 times 63 is 2394. 2394 is 42H. Now divide by 42, and H is equal to divide by 42, and H is 57, and that's going to be feet, okay, because the height was in feet. So the height of the tree was 57 feet. Okay. Okay, and that's section 1.2. I will see you in the next section.